Okay, so we're just gonna let Chris get cracking here. Chris, come on up. Everybody give Chris a round of applause. He's Chris Keathley, everybody.
Hi. Yeah. Thanks everybody for coming out. Before I get started, one other announcement. A week from today, at I think I said 6 o'clock, 6:30, we're doing the very first official Elixir meetup. So if you want to come to that, it'll be here, and we'll be playing with Elixir and getting to know each other and stuff like that. So if any of the stuff that I say today in this talk is interesting, we will probably talk about more of it. So that should be fun. So I want to talk about functional object-oriented programming. And this kind of came out of a really interesting interaction we had on Slack, in our ChawDev Slack. And it's this notion, somebody posted a YouTube video, and the basic premise is this. OO is evil. It is straight the devil. It is awful. There's nothing good about it. All these things are terrible, and the world is awful. And our lives are terrible. And this is what people say on the internet. And I think this is I think if you talk to certain people, you'll get this a lot. And I think that this is really bad. Because this is not how to have a conversation at all, turns out. This allows for because this isn't actually you can't actually have a discourse about this because you've already made your point so solidly, that you can't actually interact or maybe come to a happy medium or figure out what the good parts of OO even really are. So I think that this is something I'm going to try to avoid. I don't think this kind of discourse is useful. I also say some of this stuff may be complicated, it may be new to you, and I really want this to be more of a dialogue. I really think this stuff's really important, and I want us to be talking about it more. And so if you have questions, please just shout them at me. That's totally cool with me. So, and I think we maybe get more out of it that way. So I started thinking about this by thinking about best practices. And I've been thinking about best practices a lot. And I've been probably for the past 6 months to a year, I've been really thinking about we have all these best practices, especially in OOP. So what are some of our best practices? Separation of concerns. What else? Dry. There's a lot more. Well, these are some of the ones I came up with. You have solid and dry. You have all these design patterns. There's a book that thick, filled with nothing but design patterns. And then there's more. There's more of those books. We have law of Demeter. That's so important, we call it a law. And yet we still violate it, because apparently there's no code police. We have small methods. We have a range of ideas that all end with 2Ds. TDD and BDD and DDD, and I think now there's HDD, and TDD can stand for types or for tests. It's ridiculous. But we have these things for a reason. These are there to serve a purpose, right? And I think the purpose is something more like this, right? I don't think OO is evil. I think OO is complex. I think a lot of programmers will tell you that. Unless you're talking to closure programmers, and then they'll say something like OO is complected, because closure programmers. And I don't necessarily think that this is false. I think it's still lacking in some nuance, and I want to try to dive into that. But before I go farther, I want to actually stop and define what we mean when we say complex, when we say simple. So complexity. Who knows what complexity is? What? What's complexity? Exactly. Which definition, right? So complexity can mean a lot of things to a lot of people. So I want to give a very concrete definition here. And I'm going to go with the definition of consisting of many different and connected parts. So things braided together. And I'm really standing on the shoulders of giants here. There's a fantastic talk by Rich Hickey called Simple Made Easy, and you should go and if you want to hear more about this stuff, you should go and watch that talk. So we have this notion of complexity. It's this thing of many parts all bound together in a knot, right? And if you think about some of your code, maybe you can imagine where you have some complexity in your system. Contrast that with simple, which means composed of a single element, a single thing, one braid. In more OO terms, I think we call this decoupling. That's the term that we tend to use. And decoupling is weird because it has its own connotations. It can have its own meaning. I'm going to try to mostly stick with using the words complex and simple. But no, if I do say decouple, that's what I mean. It's the act of making something complex, turning it into something simple. So the interesting thing about decoupling and best practices, if you look at that list of best practices, they are all there to do essentially the same thing. They are all there to do that. That's why we have best practices. They are all designed to do this, to take complex things and make them simple. And we have hundreds of these things. I think that's interesting because it's sort of a tacit agreement that left to our own devices, we will inevitably create a ball of mud. Like the notion that we have these best practices, that we have things that we call laws, is really sort of saying that we're not good at this. And I don't think that that's, I don't necessarily think that it's always that we're not good at it, but I think we often choose tools and we don't necessarily give the kind of thought process that we should into making these sorts of decisions. Because the thing is decoupling takes discipline. To follow every best practice takes discipline. It takes you sitting down and actually thinking about what you want to do and pulling things apart and being very intentional. And it takes experience, and it takes learning when best practices conflict. Which ones do you want to accept, and which ones are you gonna what trade-offs are you gonna make? The thing is once we have decoupling empowers change, right? Because decoupling on its own is sort of like, who cares, right? But we do all this not because it is good in of its own right, but because it empowers change. And change is the only true constant in software, right? And I think, just not to get on too much of a soapbox here, but I think we put up way too much fight against change. I think we have a serious problem with resistance to change. And you see that when your customer, your client, or your business alternative comes to you and they said, hey, that thing you just built, it's not quite right. We need to enhance it. We need to do something else. And you get mad, so mad. Why are they asking me to do this? Oh, that really sucks. Do they not know how much time it's going to take to fix that thing? That's a problem that we've largely made for ourselves. We are there to empower just those understandings and those learnings and empower that change. It is ridiculous of us to expect a business client to come to us with all the answers. That is actually ridiculous. We obviously are going to ask questions of them. We're going to ask them to do research, and we're going to ask them to form well-formed ideas. But at the end of the day, there are unknown unknowns, especially if you're lucky enough to work in something that's actually truly cutting edge. You're going to try things, and things are not going to work out. I think we have to empower change. And I think, by and large, we choose tools that affect our ability to make change. And I think OO is part of that problem, or some pieces of it. So what even is OOP? What is it? There's a lot of stuff about object-oriented programming and a lot of different languages that call themselves object-oriented, right? JavaScript calls itself object-oriented. Who finds JavaScript to be object-oriented? No one? Python's object-oriented. Is Python object-oriented? Do you guys feel okay-ish? Okay. What are the defining characteristics of an object-oriented language? Having the object keyword. What else? Polymorphism. What else? Encapsulation. Ruby. What else? There's a lot, right? What are some fundamental things? Inheritance. Data hiding. Okay. So this is the list that I came up with. I made an informal poll of all my coworkers last night, and we came up with this list. And it's a lot of the same stuff. The thing that I think is most characteristic is that we often define OO as behavior and data walking together. Right? You've hidden this data inside of this, or excuse me, you've hidden this data inside of this object, and now you have behaviors on top of it. Obviously, inheritance, this word of encapsulation, which can mean 1,000 things. You have this notion of like domain modeling, which is kind of like encapsulation, but people will get mad at you if you make that comparison. Methods and state, polymorphism. You get defined structures out of it, and this whole notion of metaphors, messages, and data hiding. It's interesting because a lot of these things are not unique to object-oriented programming, which we'll see. And a lot of these things actively work to create complexity in your system. Just by definitional, they do. So let's look at what that is. And remember complexity, right? When we say complexity, we mean things bound together, right? Things intertwined. The first is really the whole point, which is mixing behavior and data. You have made a complex system by the very notion of merging behavior and data, right? It's two things that could be pulled apart, and you have intertwined them. That's a trade-off we make sometimes because it might make sense to us, or it maps better to our understanding, or in short, it's easier, which I think we often conflate with simple. Easy would just mean, in this case, close at hand, close to our understanding, not having to gain a new knowledge. Right, but this is a natural piece of complexity that happens as part of just writing object-oriented code. Another is inheritance. Inheritance, again, it's the definition of it is you have made things complex. You've you've assigned this hierarchy to some object somewhere. It now magically has methods on it that are hard coupled to the thing above it. That's a piece of complexity. It's a piece that you would have to decouple, or if you in the event that you need to change it. The notion of methods themselves, being able to sort of wrap up your behavior in your data again, right? It goes back to the whole thing. And then this one's kind of interesting, and I don't have a good word for it, but it's the lack of actual proper boundaries, right? Because we have data hiding up until we don't, up until you return a piece of state that this object's holding, and now you've leaked it throughout the rest of your system, and this is why we have law of Demeter, right? Because you're not supposed to do that. And I think we actively choose things that have bad boundaries. ORMs are a good example of this. Specifically things like active record or the Django ORM, which kind of follows the same active record pattern, and others. This is an actual, we actually leak state out. We leak knowledge about deeply nested data through our objects. And finally, I think we do have a problem with state. State is complex. And state is complex because it's not just data, it's not just behavior. State's complex because when you have state, it doesn't matter if it's mutable or immutable, and if you can change it and replace, and with references and whatnot. If you can take a piece of state and you can change it, and something else can come along and can try to get a reference to that, you have now coupled your behavior and your state with time. At what point in time did you call this thing? And you will get a different result. If you can say dot update, and then get a different result, you have a problem. Because you now have to recreate the world in a very specific way. You have a problem with debugging. You have a problem with actually being able to go in and sort of test things, right? Because what do you have to do to test? We've all done this, those of us who do OO, right? How big is your world that you have to build when you need to write a test? The bigger it gets, that's the reason. So how do we actually take OO and we make it simple? How do we actually start to maybe move past some of these characteristics and try to focus on simpler things? The first, I think, is messages. We have to embrace the notion of messages and sending messages between objects. You can make this analogous to could I turn this into an HTTP request? Right? Could I take data and send it to something else? and have that work out still. Right? We have to think about these actual things being decoupled and sending messages to each other. The second is polymorphism, and this isn't even like isolated to OO. You can do this in functional languages. People don't necessarily, people in functional languages talk about it. It's a thing we tout about OO, but I think we need to rely on this, right? The next time you go to make like some factory, abstract factory that generates factories for your factories, and you're drawing, like making big switch statements and everything else, like just think about how could I just do this with polymorphism instead? Next time you're creating a pretty complex if statement or other conditional, think about how could I just do this with polymorphism? And specifically, you really want to think about polymorphic data. Like how do we make data polymorphic? And unfortunately, in a lot of OO languages, we don't have any other choice but to use something like a value object, right? A small object that wraps a piece of data and does nothing but give you read-only access to that piece of data. That's often the only way we can get true dispatch and true like polymorphism with our data. Some OO languages have better allowance for that kind of thing. And I think we also need to just focus on like using namespaces and functions. Like functions are easy. They're so easy. You give them data, they return you data. They're so easy to test. Like it's phenomenal. We should be leaning into this a lot more. We need to focus on data transformation, right? We need to focus on what happens when I take this object and it moves throughout my system. And to touch on the point of encapsulation, you can do encapsulation with functions. The function doesn't have to, you don't have to know deep things about what that function's doing to hide business logic. You can hide business logic in a function still. The difference is that it takes data in and gives you data back, right? So you, the caller, you at the call site, can actually get your data back. You can understand better about what's actually happening, and your function's more reusable. So that's a lot of big ideas, and it's a lot of hand waving. And I want to like try to show an example of this and this kind of way of thinking about things. And if this example seems contrived, I promise you it's not, because this is like almost verbatim something I pulled out of a code base I was working on 2 days ago. So it's a real thing. All right, so this is Ruby. Hopefully everybody understands a little bit of Ruby. If not, it's a very easy to sort of read language. But the bulk of our work is down here at the bottom. It's this new ticket service. And the idea here is we're creating a ticketing system for our application. So if something goes wrong, users can generate new tickets. They can say, hey, support staff, go fix the thing. It's broke. Why? Because it's broke. Whatever. So what do we do here? This is like a pretty standard service class type idea. We create a ticket. We just pass in some params for that ticket. We create a ticket, and we then we send out some notifications about it. So we call this ticket notifier send alert about the ticket. Inside of our ticket notifier, we get all the on-call staff. We loop through each of the staff, and we send them an email. The email is just a wrapper around sending an email. It doesn't matter what that email is. It could be an HTTP request, or it could be, you could actually have your own SMTP server, I guess, if you want to do that. And you could send emails. And then finally, up at the top there, you just see we've got a class that's wrapping, some staff repository where you can execute SQL queries. Does that make sense to everybody? Yeah. Cool. So what's the problem with this? Does anybody think that this is a problem? Yeah, you have hard couplings right there to tickets and ticket notifier. To some degree, that's okay, because this is sort of your shell, right? This is sort of the shell. The bigger problem, I think, is that you've got a hard coupling to staff inside of the notifier here, and you've got, you know very intimate details about this mailer. But there's actually more subtle things. There's subtle problems with this. If you look at the actual mailer, it takes a user and a ticket, right? And then supposes that the user has an email, the ticket has an ID, and the ticket has details. If those things change in your database layer or in your ORM or whatever it is you're using, you now broke that, right? That's 3 miles away from the actual code change that you made, but you broke it. So how do we actually start to clean this up? So we're going to treat this ticket service, this create ticket thing, as sort of our shell, the shell of what we actually want to do. And we can really easily just, like really fast, just bring just the staff, the on-call staff, out of the ticket notifier, and then just pass it in, right? That's a tiny change, right? Just pass in data. But now, think about it. You could actually run those two things, you could stream those two things now. You could do that right in your shell. You could stream all of the on-call staff into that other thing, right? You've opened yourself up to be able to do actual concurrency. And that's, like a very, very straightforward thing. And so, and what you've done here really is you've separated arrangement of your data and the work that you're going to do on the data. And again, these are just functions, right? They're not objects that we're newing up. Okay. So let's say we want to actually send the user who originally created the ticket an email, along with all of our staff, just to let them know too, like, hey, we got your ticket, you have an email coming, we send you this email to like confirm it. How do we do that? Well, the easiest way is, again, instead of passing users in now, instead of trying to like create more objects, let's just use data. Let's just get the emails out. We'll map all of our staff. We'll just map over them, and we'll get their emails. We'll basically transform a list of users into a list of emails, and then that staff plus ticket.email is just like a concatenation. We just like take the array we have, and we add the ticket, the original email from the person who submitted the ticket, and then we just pass emails in. And now emails is even simpler because we just loop over it again, and we don't have to have any knowledge about what it means to be a user, right? We just send an email. You can use this anywhere. It doesn't matter what the objects are anymore in your shell. You just get data and just pass data around. And obviously, we still have tickets that, and there's still kind of deep knowledge about a ticket there. Given that this is called a ticket alert mailer, maybe that's okay. The other thing that you can see when you do this now is you have two classes here. You have ticket alert mailer and you have ticket notifier. Both have a send alert function on them. And by the way, I'm using classes here in Ruby because it's the fastest way to kind of create what I would call a namespace for these functions. You use whatever makes most sense in your language. But I've got two different functions, right, that do almost the same thing. We've just added indirection here. Why do we need that? We don't. Just get rid of it. Like, you don't need any of that. So you can actually now by just doing the simple act of like separating arrangement and work, and by using functions, you have exposed places of duplication. You can make your system simpler. It can now just send emails. So let's say the inevitable happens, and someone asks you to change this. They want to add some flexibility because our on-call staff they don't have it on lock yet. They're way too slow. They've got all their email notifications turned off because seriously, who has email notifications still? That junk is awful. And so instead, we're going to say, actually, you know what? We want to alert them in Slack because nobody turns off Slack notifications. And we'll just alert them in Slack. Well, how do we do that? Well, because we already have our data in our shell here, we can just map our staff into a list of Slack names, and then call a function that just sends alerts to some Slack channel with their names in the ticket. This is almost identical to our mailer, right? We've created the same interface, right? They're the same types of functions. We could actually swap out these two things if we needed to with our own sort of behavioral polymorphism thing if we needed to do that. And again, we're not using objects here. We're not like hiding state away. We're just using functions. The great thing is that all this stuff is reusable, right? Because again, we're just talking about data. So in the event that I don't want to actually use this service, but I want somebody to maybe post a form into my web app and then render some JSON back to them, I can just do that. Right? It's no different. It's like this action, this create action, which would be for your post, your creation of a ticket. We do the same thing. It's all the same stuff. This is our shell. We get our data. We marshal our data out. we do some side effecting things with it, and then we render something back, right? And this is like a very intuitive way to write program. I think a lot of us can think really clearly in sort of these imperative steps like this. I think that's really powerful. And there's a lot of power that comes from just thinking about what is the data we have, pass in data to functions and have them do things. A good litmus test of this is could I make any one of those things an API call? Right? Again, I haven't exposed the business logic behind any of those functions. So could I make them an API call? Could I make them call some other box on my network? Right? Could I call some other service? Could I make these things concurrent? Or could I make this a streaming operation? Right? These are things that you get. If you can actually say yes to these, you know you're doing something right. Could I put a queue in between these things? Could I just dump this work into a queue and then have it do something? I think you have to think about your data. You have to think about the data we want to get out. We have to think about the data that we're going to be passing around. We have to use functions that accept data and return data. I've said this 1,000 times. And I think if we do those things, we can allow for the change. We can actually empower the change that we need to be empowering for our business. So, thanks. We definitely have time for questions and such still. So if anyone has questions, I'd love to talk about this more. Yes?
Since not everyone read.
Yeah, there's, oh yeah, sorry. So the question was other resources if you want to go learn more about this stuff. There's a giant list that I posted on Meetup with some of the highlights. The first two things you should absolutely do when you leave here, if this stuff was intriguing to you, is go watch Simple Made Easy by Rich Hickey. It's fantastic. And then go watch Boundaries by Gary Bernhardt. And he talks a lot about the same things and utilizing sort of the best parts of OO. This notion of being able to kind of hide, not hide, but add metadata in a lot of ways, add some vocabulary to your data in a very meaningful way, and he does it using kind of functional principles, and it's a great talk. Other than that, there's a giant book list, which I'll post on Meetup. Anything else? That all just made sense. There's no controversy. I made fun of ORMs. No one's gonna tag me on that. Yes. Mm-hmm. Mm-hmm.
I like the way you did your.
Yeah, absolutely. I don't know that I can repeat all of that for the benefit of the viewer at home. But the basic gist was TDD and BDD are useful beyond the contexts of OOP, and I completely agree with that. I don't disagree with that at all. I think I've said this up here before. I kind of like testing because it helps me. It forces me to answer questions about my system, and it also does prevent regressions and those sorts of things. And I think that's absolutely true. You should still all those best practices are not necessarily bad ideas, and you should still use them to some degree. Especially testing. Testing is a good thing. The thing I think testing. The only argument I have against testing is that when you do test, I'm I find that a lot of times people test in such a way that let's put this. One of the unfortunate side effects of writing a lot of tests is that you can necessarily bake in bad design. Like you can necessarily or not necessarily bad design, but coupled design. Or, and this is like the whole notion of trying to use mocks and stubs and isolate things and all this stuff. And I think that's really tricky because tests make change harder. They necessarily make change more complex. That you've complected, God. You've made your code more complex by binding it to this sort of external test thing. I think that's a trade-off you can make, and I think it's probably a trade-off you should make for the time being. I don't know. I'm still doing a lot of thinking about testing right now. Yes. Sure.
But so
Sure.
what approach do you take?
Yeah, I think that's a great question. I tend to put, so often I do a lot of web apps. I'll preface this with some of my context. I do a lot of web apps, and web apps sort of naturally segment themselves into actions, especially if we're doing RESTful stuff. And so I'll move. The thing is whenever you take an action against some service somewhere, you have to think about what data do I need to accomplish these tasks? How do I get it? And it's probably to some degree isolated inside of that action. So marshal the data necessary in that action and then pass it into the rest of your stuff. You can certainly move the actual querying logic into other functions, and that way they can be more reusable or composable. If you want to say all support staff and also their managers or whatever. You can obviously write functions to do that sort of stuff. And I think that's good, and you should try to reuse those things. But I end up putting quite a bit of querying, not raw SQL or something in my actions, but you have to marshal data somewhere, right? And I find that if you have a shell that marshals data and then just does actions, that's pretty reasonable, and you can kind of start to see okay, this is getting unreasonable. And that's an intuition thing. You just have to do it a lot and kind of gain intuition about it. Any other questions? Yeah, okay, cool. Well, thanks everybody for coming out. Like I said, if you want to talk more about this stuff, come up and find me whenever. I really hope this, we can start maybe a dialogue about this stuff, and because I really think it's honestly really, really important. So anyway, thanks everybody.
Thanks, Chris. Next week, we believe have Tim. Tim, you're talking next week, right? You're going to talk to us about which database is the right DB to use. Also want to highlight Chattanooga UX Meetup and Center are bringing in Jared Spool, not this Saturday, next Saturday, the 20th, that morning, going to do a workshop and talk. If you've not seen him before, he's a fantastic speaker. He's going to be talking about information architecture, so definitely some overlap with the kind of stuff that I'm sure most of us do in our professional lives. So, that said, even if you're not that interested in the subject matter, he's just a great person to go watch him speak and pick up on his speaking methods and that kind of thing. All right, guys, thanks again. We'll see you next week.
Also, Elixir meetup next week here.
Elixir. Alchemists.